How many roots are you looking for? 3. Now, based on some previous problems, you might say, we might have some triple roots up in here. Or maybe a double root and then a single root. It might kind of happen like that. We'll see. We'll see what happens. So we're going to set this equal to 0. And that's going to give me x cubed plus 125. And then the obvious thing to do is to move the 125 over. And that's going to give me x cubed. And I'm going to cube root that to solve it. X by itself. The cube root of negative 125, you might be tempted to look at this negative and say, well, that's just not going to work because I'm rooting a negative. It's totally okay if you want to root a negative as long as you're taking an odd root of that negative. So negative 5. There we go. Well, I wonder if it's a triple root. I don't know. Let's see. Let's take a look at the graph. Let's see what this thing looks like. So we better have 3 answers, even if this is the same answer 3 times, right? So let's see what we're dealing with here. There we go. Which one is? There we go. That's it right there. Ah, that's it. That does not look like a double root to me or a triple root. So we have 2 more roots to find. Oh, what are we going to do? What are we going to do? I have an idea. Let's do it. I need 2 more roots. Got to find all 3. So how about we go back to this step, and instead of doing this, which is not wrong, that just limits our possibilities, we go a little further. And we treat this like the problem that it is. This is the sum of 2 perfect cubes. Ooh, fun stuff, huh? Right? Remember this formula? I sure hope so, because it was in the previous lesson. A cubed plus b cubed, and that's going to be a squared, ab, b squared, and we're going to just have same sign here, opposite sign here, always positive there. And in this case, a is x and b is 5, because 5 times 5 times 5 cubed is 125. So we're going to put x 5, x squared, 5x, and then 5 squared, which of course is 25. Same sign, opposite, always positive. Now, we're going to set each of these factors equal to 0, and when we do, we have x plus 5 equals 0, which gives us negative 5. We already had that. Yay, there's some redundancy in our work. Okay, now we're going to have x squared minus 5x plus 25. Forgot how to write for a second there. Equals 0. And if you want to try to factor that, good luck. It's not going to factor unless you start playing with some complex numbers, which we're going to have to do. So hopefully, let me slide this over. This that I'm about to write is going to ring a bell, and it's going to come in handy very much so later. Quadratic formula. Good old quadratic formula. It is fun stuff. You know, you could derive that by completing the square with ax squared plus bx plus c equals 0. Fantastic. Ha! Just gives me the chills. I love it. All right. No, I'm not sick. All right, b is negative 5, so negative b would be positive 5, plus or minus the square root of b squared, so negative 5 squared, minus 4 times a, which is 1, times c, which is 25, all divided by 2a. Let's keep working on this thing. So we're going to have 5 plus or minus. By the way, this is going to be x equals. Okay, we're looking for 3 answers. We already found 1. These are going to be my other 2. I'm going to have a plus something and a minus something, and then divide by 2 there. Okay, that is 25 minus 100. That's negative 75. Oh boy. Oh boy. What do we have here? Well, we have a negative 75 under a radical, so let's just pause for a second, slide over even more, and take this negative 75 here, write it in red so you can't see it. And then we're going to break that down. So if you have a negative square root, that is a complex root, so we're going to have an I in the front. That's the same thing as saying the square root of negative 1. If you want to write that, you could. Negative 1. So we have the square root of negative 1. Let's break this up into a perfect square times, well, a non-perfect square, 25 times 3. And so we're going to have, let's kind of go in a different order. 25 is 5 when you square root it. And square root of negative 1 is I. And square root of 3 is, well, irrational, so we leave it under the radical. So my final answer for this one is going to be 5 plus or minus that stuff right there, 5i square root of 3 over 2. So we're going to have 3 answers, And there's one of them, and that's the one that shows up on the x-axis. And here are complex solutions that don't show up on the x-axis. Do they exist? Yes. Then why are they called imaginary? Because someone named them the wrong thing. Yeah. Makes me angry. But there are some really cool videos on YouTube, if you're into this kind of thing, where they talk about what the graph of a complex solution would look like, and it's really more like three-dimensional, and it twists up off of the graph and it turns around. It's glorious. It's wonderful. And if you're thinking, yeah, that wouldn't exist, it does. It does. Don't get me started on how imaginary numbers do exist. Just don't even get me started.